just the time. Here, we will actually try to show you an issue as to why it can push you into doing a FSDP versus a DDP in PyTorch, which is a pure data parallelism distributed versus a fully sharded, where you also optimize the model through sharding it, actually, the model weights. So we are going to run this particular PyTorch job. The name is all variabilized here, so the name of the job will be FSDP. This cannot change. This can change. And then I have to supply it with some inputs as to what is the rendezvous backend. So it is my etcd database. So where is it located in the Kubernetes cluster? So I'm defining that host name of the etcd host, the port number at which it will be available and all that. So you can see all this. And then there is a rendezvous ID. It's a unique ID basically to identify the job itself. What is the minimum replica? So we will start basically first with one replica. So I've just copied this code here. One replica min, one replica max. Okay. And then in the worker, you can see that the Cloud Garage and this image is my own image. Ideally, if we had more time, I would have shown you how to build a Docker image to actually run a fine-tuning job. But I've already containerized that part of the code and loaded it as a publicly available image in my Docker Hub account. So this is the image that we will be, which has the fine-tuning.py and the instructions to do whatever it's supposed to do. Okay. One replica. Okay. So num workers, let me see here. Num workers is 1, GPU per worker is 1. And then the model is LLAMA2 7 billion HF. And then CMD, whatever that is with that. And that CMD, we are supplying that as a variable to the command that will be run inside of the container when the container starts. And my GPU limits and requests are 1. So it's 1, 1, 1, 1 all the way, everything 1. Okay. Let's take this particular set of inputs and we are going to run a PyTorch job. So as of now, if I say kubectl get PyTorch job, note that earlier I was saying kubectl get TF job. This is PyTorch job. There is no job. Now we will deploy this particular job. So you can see that now you will have kubectl get PyTorch job. There is one job running. The name is FSDP, but it's of the kind PyTorch job. If I say kubectl get pods, you can see that etcd anyway we had deployed, right? And there is no parameter server here and all that. It's just one worker running to execute something. And we will say kubectl logs FSDP worker 0. Okay. You can see that this particular job has started running. Okay, which is actually a worker trying to do something. And what is that something? The entry point is basically, it will run this particular fine-tuning.py script. Okay. And on the model, that is the llama, the Hugging Face. So you can see here, the token has been saved to Hugging Face token and all that. It has logged in into Hugging Face. It will run this particular thing. It will also download that model. Would have already downloaded that model and all that, from Hugging Face and all that. Now, at this point, you can see the same thing, clearing GPU cache. So before it will start, as a best practice generally in your code, it's always wise to actually clear your GPU caches so that this will take about 5 minutes, literally 5 minutes or 6 minutes also. Hence, I will unshare. We will wait for 6 minutes and we will see an error. Let me tell you, we will not be able to complete this training run. And that is where I want us to observe. You are not talking about a small model. You are talking about a LLM, large language model. And with that size of the LLM, maybe I think 25 GB or whatever, maybe whatever it is. But there's a lot of associated things with the LLM, weights and all that. Everything put together in this particular case with L40S, with our batch size equal to 3, we will not be able to fit that everything into one single GPU. Right now we have said one worker, one GPU. Everything will not fit into one GPU. Hence, you will see an error. The error will be CUDA out of memory or something like that actually. So right now it will take its time. So we will have to wait for that error to pop up. Once that error pops up, that becomes a baseline for us to actually deploy more number of workers or a distributed. Right now, this is not distributed. This is one replica, one GPU. Then it gives us enough reason to expand our distributed nature of the job so that we can bring in more GPUs such that your model weights, everything is sharded across, and then you can fit everything into a cumulative aggregate of the GPU capacity as opposed to a single GPU. Okay, so see, it tried to do a run. And do you see this particular error?
Out of memory.
Tried to allocate whatever, GPU 0 has a total capacity of this, out of which this is free, process blah, blah, blah. But essentially what happened is that it tried to run a fine-tuning job and then it failed because of a out-of-memory error. So in the interest of time, I will now say kubectl delete TF job, PyTorch job.
And then we'll use parallelism across.
FSDP. Exactly. So let's see, the pods are terminated or not. The pods are terminated for the job. I will also delete the etcd just in case if there is some residual state of the etcd. Okay, so let me just delete the etcd. So as of now, there are no pods and no PyTorch job running. Okay.